Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhaumik, and in this series of lectures of wave optics, today's topic is polarization. So what is polarization? Polarization is a phenomenon. Polarization is a phenomenon which actually shows the transverse, which is due to the transverse nature of light wave. Okay, so we know there are two types of waves. That is, one is the longitudinal, that is transverse. What is sound? Sound we can say that is longitudinal wave. Longitudinal wave. That is, if the direction of propagation is this side, the particles will tend to vibrate this side. Actually, the air particles there is a pressure oscillation. That is the air fraction and the compression. Sound is, that is why I can say it is a longitudinal wave. Now what is EM wave or electromagnetic wave? Electromagnetic wave is my transverse wave. I can call it as transverse wave. So why is it transverse wave? Because see, this is the direction of propagation, and in this direction my electric field is oscillating, and in this direction my magnetic field is oscillating. So the particles that are oscillating in the direction that is 90 degree to that of the direction of propagation, that is called transverse wave. Okay, so this is the basic thing what we need to know. And now let's see what is exactly polarization. See, ordinary light will have vibration in all direction. Ordinary light will have vibration in all direction. This is ordinary light. Let's do one thing. Let us take two main direction, this, and let's take the component of all the directions here. Let's say this is one vibration, and I am taking the component like this. Here, this like this. So now what is it is happening? I will represent it like this. This is the component along y-axis, is the component along x-axis. So like this. So if I take all for this one, say for this one, this is already in this component, this one. So I will represent them only by the two axes. All the components in all the directions that I am taking the components only in two directions, this is x and y, and I am adding them. See, and that I can actually represent it like this. Suppose I am showing like this. This is I am seeing the side view. This one I am seeing from the side. So this is my top direction, and this dot represents I am coming out and in. Say dot is coming out and cross is going in. This other thing already you all know. So this is my dot, that is it is coming out, and this up and down, this arrow, that is it is in the plane only. Now this is my light. This is my unpolarized light. I am representing unpolarized light in this fashion. Now this unpolarized light I am passing through a crystal. This is a polarizing crystal. There are many polarizing crystals. This is a polarizing crystal. After passing through the crystal, what is happening is that I am getting only oscillations along one direction. The oscillation along the other direction is not there. So this light is called polarized light, and this light is called unpolarized light. I think this is clear now. What is polarization? What is unpolarization? Polarization will have vibration along only one plane. That is vibration along only one plane. This is my polarized light. Now what is this? This one is called polarizer, or is a polarizing crystal. And this crystal, if I go into this crystal, there will be two planes. One plane is called plane of vibration, other plane will be plane of polarization. Let's analyze these two planes. Now this light is entering and going. Initially it was unpolarized. Initially this was unpolarized and this was the light. Now what is happening? Inside there is one plane which will contain the vibration. See, this is the plane. Suppose this is my plane. I'm showing it like this, and I'm trying to show in 3D. So these are my, see, actually only this component of vibration is there. That means this dot, what I'm showing in 3D here. If I can, okay, I'm removing the dot here. I'm showing the dots in 3D. Then I think it will be very clear. This orange ones. Okay. This is called the plane of vibration. This plane of vibration will contain the vibration as well as the direction of propagation. That is, it is propagating in this direction. So it is containing the direction of propagation as well as the vibration. Now what is the plane of polarization? The plane of polarization is that plane which has no vibration in it. Let's say this plane. This is the plane of polarization. It has no vibration on this side. Okay. So we understood what is plane of polarization and plane of vibration, and we also should know that plane of polarization and plane of vibration are mutually perpendicular. Plane of polarization and plane of vibration are mutually perpendicular. Okay, I think this much is clear for everyone. Now let me see one thing. This is my unpolarized light. I am passing it through a polarizer. It will become polarized, only one. I am again passing with the polarizer. I'm making the plane of polarization, or rather the plane of analyzer, that plane M. This is 90 degree with respect to this. Here I will not get any light. This will be no light condition. No light will pass, because just see, the entire vibration is along this one, this along the dots, and this plane of polarization is only along the dot. This is the plane of polarization. Okay, this plane of polarization. This plane of polarization is only along the dots. So it is nullifying all the vibrations along that plane. So there is no light, or the intensity is 0. I think this much is clear. Okay. What if there was some angle? What would have been the intensity? We'll come to that point. So that is all for this lecture, and in the next lecture we are going to learn about Brewster's law, where I will be showing you that tan IP is equal to mu, and how refraction can cause polarization and the condition. So thank you, and please subscribe to our channel and click on the bell icon.